Hey everybody, in this video we are kicking off officially lesson 2, a limits introduction. So we are officially going into it, but yeah, guess what? We're warming up with another piecewise function. So I just think that this is a really great tool for working with limits, okay? Now, a couple things. I got this example from somewhere else and someone else made this. I find that curly bracket at the end odd. It's not supposed to be there. I imagine some teachers put it there because they don't know how to use the math type stuff correctly, and there's certain programs that will only give you the left hand bracket with the right hand bracket, so you kind of don't have a choice. They both get drawn. Side note, if you don't know how to draw that curly bracket, if yours is always really ugly, the trick is you draw a tall skinny S and then you draw a backwards tall skinny S. All right, or vice versa, you draw a backward tall skinny S and then a forward tall skinny S. You're welcome, if that just helped change your life. So I erased that other one. And the other things I don't like, I don't love that it's not written with a comma. It has the word if. That's a little unnecessary. I'm never a fan of inequalities when I could have interval notation. That's the next thing. And worst of all, this is in reverse order. This is the rightmost equation going to the leftmost equation, and I just find that to be rude. So you'll see what I mean when we start graphing. But let's get into this. So I'm going to start with this one right here. This is when x is less than 0. And right here, while we're, working on this, x is less than 0 means from negative infinity, right, until 0 with a parenthesis. So that's where I'm looking. Now, what is this graph, you ask? This graph is a parabola, and it's simply shifted up 1 unit. No funny business, nothing interesting going on, and it's an open circle that 1 unit up. So in blue, I'm drawing a beautiful open circle right there. That happens to be the vertex. And then I'm going to follow my classic pattern only to the left of 0. Over 1 up 1, over 1 up 3 if I had the room, over 1 up 5, over 1 up 7, and so on. And carefully with a nice smooth curve, I connect the dots, and there we go. Dunzeroni. Next up. Next we're going to look at this middle piece, and there is the interval with an inequality. And then before we do that, let's write it down as an interval notation. It's going to be bracket 0, 2, close bracket. So that's going to be over here between 0 and 2 in this region right there. Okay, now before I start, do you remember that I gave advice, and it's going to apply actually to this one as well, to what to do when you have a linear in piecewise? What is the efficient, quick, easy, you'll thank me for it in the future advice I gave? Linear in piecewise advice. Did you write it the other day? Did you get it from lesson 1? Do you know? The linear in piecewise advice was to evaluate at first and or, sometimes you don't have a first and or last, you only have one or the other, first and or last x values connect the dots, exclamation point. So if you don't know what I mean, you're about to find out. So my first and last points. My first is 0. Can I spell first? Maybe. I don't know. That's the first one right there. And there is my last x value, right? So I'm going to plug those in one at a time, get the corresponding y value. That makes ordered pair an ordered pair. And then once I have an ordered pair, connect the dots. Instead of trying to find my y-intercept, now, yes, of course, I know this is x plus 1. I could simply start at 1 and draw it. But like, I'm just showing you because I promise they don't always work out to be nice like that. So let's go ahead and plug in. So first I'll do x equals 0. And I get 0 plus 1, which is 1. So then the ordered pair is 0, 1. That's the point. And then when x equals 2, it's 2 plus 1, which is 3. So the ordered pair from that info is 2 comma 3. Okay, oh sorry, it's covered up by the little bubbles. So 0 comma 1, 2 comma 3. They're both closed circles because it was both closed brackets. And then you connect the dots and you call it a day. That's it. It's just easier this way. Okay, you're done. This way, if you don't have the y-intercept or it's a bad y-intercept, you're fine. Okay, so there was that one right there. And then next up, we are going to be looking at this one here. And do you see what I mean? From the bottom to the top, I was getting from left to right. It's kind of silly. Here, x is greater than 2. What is that as interval notation? Greater than 2 would be 2 comma infinity. I never draw infinity like that because I usually, every time I try to draw infinity like this, I don't know, if I'm going too fast, somehow it starts and I end up like, I don't know, standing him up and making like a snowman, like an 8. And I don't know, I don't get him to lay down. That's why I always draw 2 circles separately. I don't know. Anyhow, so I have another linear. So I'm going to do what I just did a few minutes ago. I'm going to plug in my first. Now I don't have a last. The last is infinity. So I'll just apply the slope from there. But let's see that. So 2 times 2 minus 1, 4 minus 1. So this is when, obviously when x equals 2, right? And that's 3. And what ordered pair does that lead us to? 2 comma 3. So if I go to plot that down at 2 comma 3, I'll have an open circle, which happens to overlap exactly where we just were. Just like that blue one overlaps, but it's open, that pink one, right? So the green point is open right there. And since I don't have a last point, I'm going to apply the slope. And what was the slope? Vertical stretch, it's 2. Up 2 over 1, up 2 over 1. There we go. Beautiful. That's our piecewise. Now, what do we notice about this piecewise? What's great about it is that it is continuous everywhere. Do you notice that everything picks up exactly where the last one left off, right? Now, is this a great roller coaster? Is this smooth everywhere? No, I would think that maybe the roller coaster would fly off the tracks if you built this as a roller coaster, right? It's not smooth. Is it possible to go from a parabola into a linear and make it smooth? Yeah, that's possible. Look how smooth that was, you know, pretty good. But it's also possible to connect and make it a little danger, right? You're not driving over that. So keep that in mind for future with calculus. So what is the domain? Now, you didn't even need to graph this to figure out the domain, but the domain for this is going to be negative infinity to infinity. Really, if you look at the intervals on the piecewise function, it uses every x value. And then I look at all the pieces, they're polynomials, which are smooth and continuous. So yeah, everything's being used. It's all hunky-dory. Great. So negative infinity to infinity, all real numbers, whatever way you prefer to write it. The range, we go from bottom to top. My lowest point in the range is at 1, right? Right here. It's not 0, but it's 1. The only time we're really focused on y values is range, okay? So from 1, and it goes up forever to infinity. Is this continuous? Well, we just said yes. If we check the definition we looked up beforehand, we're like, oh, the limit from the left exists. The limit from the right exists. The function is defined at that spot. The limit and the function equal each other, yada, yada. Yeah, that happens literally everywhere here, okay? So everywhere is great. If not where, obviously does not apply. Where is this increasing? Okay, so increasing, what can we look at? Well, let's highlight in yellow. Everywhere from left to right that it's going up, I would say there and there. Now, AP, it seems like they want to use the definition that we include the endpoints, but they still accept the answer where we don't. And I find including the first or last point is, sorry, College Board, pretty dumb. So, convince me otherwise, but I'm just not convinced. So, I will have, it's increasing from 0 until infinity. I tried to draw it and I just need to draw 2 circles. From 0 until infinity is when it's increasing. And then when is this guy decreasing? So I'm going to set, oops, from left to right, decreasing right along there, right? That's when it's decreasing. So actually, let's not do purple because I already used that to do the work. So let's use orange, I guess. So right there, decreasing. And that's going to be from left to right, negative infinity until 0. Alrighty, so there we have it. That's this piecewise, and we're going to get into the definition of a limit. We're going to talk about limits from the left-hand limit, right-hand limit, coming together as a whole, all that in the next video. So this was introduction in section 2, I guess. We'll call it a 0.1. We'll see maybe 0.2, and then we'll get into some examples. Hopefully this was good, great. You feel mentally warmed up. Your brain is ready to go, stretched out. If you're happy and you love it, thumbs it up. If not, be mad, thumbs me down. Questions, comments, concerns, feedback, and requests, go in the comments. Check the description box and playlist for more videos on this topic if you are looking for something specific. I know you probably have it there. All right, that's it for now. Adios.